Hi all, this is Priyadarshini working as an assistant professor in the Department of Artificial Intelligence and Data Science. Today we are going to discuss the topic called semaphores in operating systems. In the previous lecture we saw what is critical section problem. So semaphores is the continuation of critical section problem, which is a software solution to the process synchronization. So we'll first see the definition of semaphore. So semaphore has been proposed by Edgar Dijkstra. So we all know who is Edgar Dijkstra. So as we all read in the data structures itself, Dijkstra played a major role in developing algorithms. So this semaphore is also proposed by Edgar Dijkstra, which is a technique to manage the concurrent process in order to avoid the process synchronization problem using a simple integer value. So when we say semaphore, you have to remind that it is a simple integer value. It is simply a variable which is non-negative and it is shared between the threads or between other processes. So this variable is used to solve the critical section problem and also to achieve process synchronization in a multiprocessing environment. So when we say semaphore, what do we mean by that? So it is an integer variable. So this semaphore variable can be used apart from initialization. It can be accessed only by the two atomic operations. So what is atomic operation? As we all know, when we say an atomic operation in operating system, that means that either the wait operation or the signal operation will be working or executing afterwards only the other operation will be made to avail the resource. So this semaphore variable can be accessed only by the two atomic operations wait and signal. So let's see what is a wait signal. So wait signal is also called as it is also be denoted by the letter P, which means it is wait operation. So it is derived from the Dutch word proberen, which means it is to test. So remember, when wait operation is given in the critical section, in the entry section we will be requesting, so the wait operation will be executing in the entry section part of the critical section problem. The next operation is called the signal operation. So the other form to define the signal operation is V. So it is also derived from the Dutch word verhogen, which means to increment. So now let's see the definition of wait semaphore and the signal semaphore in detail. So first the initialization condition. So as I told you previously, the semaphore, if it is given as P, it is wait. So wait operation is to test. So wait operation will be executed in the entry section part. So wait of semaphore S. So this S is a integer variable which corresponds to the semaphore. So the next thing is while S is less than or equal to 0. So as I told you, S is an integer value. So in this thing, if while S is less than or equal to 0 and they have given a semicolon, which means that there is no operation after this while loop. So when while loop is true, this operation will be looping over here for a indefinite amount of time until the while loop is false. It will be looping over here itself. So while S is less than or equal to 0. So if S is non-negative operation, then this while the given semaphore will not enter into the wait part of the operation. It will be looping over here indefinitely. So when S is greater than 0, that means the condition is false. So this will break out of this while operation, and then to test if it is positive, then the semaphore variable which is trying to access will be entering into the critical section, and also simultaneously that variable has to be decremented. Why is it so? if we decrement only, we let the other process to know that another process is executing in its critical section or accessing a data source. So it should not enter into the critical section region. We will be signaling the other operations. So this is the entire part of wait operation. So in order to define wait, we are going to decrement the semaphore variable, that is we are going to test. The definition of the signal operation is that, so we know it is for signal operation. So here we are not doing anything. We are just after executing the critical region part, we will be incrementing the semaphore variable and letting the other process know that this operation has finished its execution and then it has incremented. So in wait operation, we are decrementing the semaphore variable, whereas in signal operation, we will be incrementing the signal operations. So this is the definition of wait and signal operations in semaphore. Thank you.